So in this session, we're going to look at what it takes to migrate to PowerBuilder 2022 R2. And of course, the effort involved is going to be directly proportional to how old of a version of PowerBuilder you're using. The further back you're starting from, the more work it's going to take. Anyway, first we have a legal disclaimer. And then this is the agenda. So I'm going to look at the migration process. We're going to look at some of the discontinued features that have throughout time, so that depending on what version of PowerBuilder you're coming from, you'll know what you're going to need to address. We'll also look at revised features. And then we're going to look at some specific cases, some of the areas that when you're doing a migration forward take perhaps the largest amount of time to deal with. Then we're talking about some resources for doing the migration, and then I'm actually going to walk through a migration for you. A little bit about me. I've been using PowerBuilder for quite some time, since version 1B. When PowerSoft originally developed the product and was maintaining it, they formed a group called Team PowerSoft. That was a bunch of people like myself who spent a lot of time in their forums, answering questions from other users, writing magazine articles, books, doing presentations at PowerSoft conferences. When Sybase bought out PowerSoft, I became a member of Team Sybase. When SAP acquired Sybase, I became an SAP mentor. And then now that Appian is maintaining PowerBuilder, I'm becoming Appian MPV. Still doing the same stuff though, answering questions in the forum, providing code samples, and doing presentations like this at events. A little bit about the company I work for. When I started with this company, shortly after they were founded, they were a PowerBuilder shop primarily. We have since moved most of our development into HTML5, JavaScript, Java in the middle tier, but we do have a number of clients that are still using our PowerBuilder products, and so we do have a small staff of PowerBuilder developers actively doing development still. So, migration process. The first thing you're going to need to do is look to see, are the software requirements met? Is the operating system that I'm deploying to, the database version I'm using, still supported by the new product? I did another session on the new features in this release, and one of the things I mentioned is things like Windows 8.1 and Windows Server 2012 R2 are not supported by this release. So if that's something you're still using, you may need to think about, am I going to take the risk and move anyway? Same thing with database versions. If you're using a really old database version, maybe it won't work so well with this version of PowerBuilder. Something to consider. Once you've decided that system requirements are actually met and you're ready to move forward, back up your source code, and then back up your backup, and then back up again. And you may think I'm being obsessive here, but there are quite a few times when I've been in the forums and somebody will ask, I attempted to migrate to a more recent version of PowerBuilder, and it couldn't migrate all the way, and so now the new version of PowerBuilder won't read it, and the old version of PowerBuilder won't read the migrated files, and it was my only copy. What do I do? And I'd say, well, find a new job, because your employer's not going to be very happy with what you just did. Yeah, back up, and back up again, because the migration is a one-way process, and if it fails, you're going to end up with partially migrated code that neither the new or old version can open. So you're going to always want to be able to go back to a clean copy of the source code, modify whatever it was that prevented the migration from completing, and then attempt the migration again. And you're going to be able to do that over and over again if you need to, until you can actually get a clean migration. Then run the migration assistant tool. Now, the important thing here is we're not attempting the migration yet. The migration assistant tool does not attempt to migrate your code. All it does is it scans it to see what you're currently using that won't be supported in the new version that you're trying to migrate to. And that gives you the ability to go back with your current version of PowerBuilder, address those issues before you attempt the migration, and avoid this issue where you end up with a partially migrated app. So as I was saying, once you've run the migration assistant tool, you're going to say, okay, these certain features are no longer supported. I've got to revise my code. So you can go ahead and do that. Once you've got all that cleaned up, go ahead and attempt the migration. If the migration does complete, you may still have some features you need to address, and you go ahead and take care of those. Then perform a full build and optimize pibbles. And optimizing the pibbles is something I don't hear a lot of people talking about, something I would highly recommend. In these days, you think of your hard drive, if you're using Windows 11, it does a pretty good job of optimizing the hard drive itself automatically. But back in the old school days, that's something we had to do ourselves. And the issue is you write a file out to the disk, and you write another file out, you write a third file out, and then you delete the second file. Now, if you make any changes, what the Windows operating system will do is it will try to use up that space that was freed by that second file. And what it ends up doing is writing out any new files or updates to old files in pieces as it attempts to fill those holes. What that does, though, is it fragments your files. And so when your hard drive, when the hard drive is being read, it needs to jump around a lot to read a file because it's not in contiguous spaces. It's scattered throughout the hard drive in different places, and that makes the hard drive run slower, and it can lead to errors. And the same thing is true of pibbles. The pibbles operate the same way. When you write out objects to a pibble, and you go back and delete a spot, we'll delete one of the objects in the pibble, and then you modify an object. The object that gets modified, or the new object, will actually get fragmented across different spaces of the pibble, just like a hard drive. So it's a really good idea, not just when you do a migration, but on a regular basis, to optimize the pibbles. That's an operation you can do in the Library Painter. You go in the Library Painter, click on a pibble, and you can say optimize, and it will. What it will do is it will create a new pibble with the same name, copy all the objects from the old pibble into the new pibble, but they'll be laid out contiguously, so that each object now is contiguous, and so that when it's reading the objects, it doesn't have to jump around. Just like with a hard drive, it'll make reading the pibbles faster, and it'll be less prone to error. Anyway, enough about pibbles. Once you've done all that, test, and test some more. You may get code that compiles cleanly, but doesn't perform exactly the way it did in the previous version because of some differences. The only way you're going to find that out is to run through the application and test every feature. And then once you've done all that testing and ensured the application does work properly, deploy to production. So let's go back and look at discontinued features. Now, I've only gone back through about PowerBuilder 8 here. I'm going to give you a link later on that goes all the way back to PowerBuilder 6.5. So in PowerBuilder 8, what was removed was distributed PowerBuilder. In 11.5, what was removed was the Ole Automation Server, JSP projects, the Data Window ActiveX, and the PowerBuilder ActiveX. So if you're using any of those features still, you're going to need to find a workaround to migrate to any of the more recent versions of PowerBuilder. In PowerBuilder 12, that's where the COM and Plus components were dropped. PowerBuilder 12.5.2 dropped web form projects. PowerBuilder 12.6 dropped the COM Plus runtime. PowerBuilder 2017 dropped WinForm projects, WPF projects, WCF projects, the Visual.NET assembly projects, EA Server projects, and the Web Data Window. PowerBuilder 2019 R3 drops actually obsolete, not discontinued, which means it's still in the product, but it's no longer officially supported, and it could be removed at any point. So you do want to move away from the iNet object. And I have another presentation where I talked about the new features in this version, and one of them is the open URL function that replaces probably the most used feature of the iNet object, the hyperlinked URL function. PowerBuilder 2022, this is the GA version, remove the .NET assembly target. OData database driver, the Easy Soap and Soap clients, the EJB connection, EJB transaction, and Java VM objects, JDBC database driver, and XLS FOP PDF printing. So once again, if you're using any of these features, you're going to need to come up with a workaround. Probably the most painful point here is if you're doing SOAP web services and the removal of this Easy Soap and Soap clients. Because if you're going to use like the REST client or the HTTP client, you're going to have to do a little bit more work to interface with the SOAP client, where the SOAP client, it was a little bit more of a higher level object and handled a lot more of the underlying details for you. The REST object and the HTTP object are more lower level objects, and it requires you to do a little bit more of the hands-on work to do the SOAP connection. And then finally, in 2022 R2, the DDE is marked obsolete like the iNet object. That means it's still there, but it's not officially supported anymore. It's a really good time to move off of it because it could be removed at any point. And then the Direct Connect database drivers were actually removed. So that was discontinued features. Now we're going to talk about revised features. So in PowerBuilder 9, they revised the way the source control interface operated. PowerBuilder 9, you used a specific driver for each vendor. So for Morant PVCS, there was a driver for that. There was a driver for a number of other products, which means you could only use those products. You couldn't use anything that there wasn't a specific driver for. In PowerBuilder 9, that's when they introduced the MSS CCI, which is like sort of like an ODBC for source control. So PowerBuilder supported the MSCCI, and then you could use any vendor who also supported MSS CCI. So that opened up the number of source control providers we could use. PowerBuilder 10 is where we moved from ANSI to Unicode. PowerBuilder 10.5. There was a change to the rich text data control. Prior to 10.5, PowerBuilder was using an OEM of a product called HiEdit, which had been long discontinued by the vendor, and so they switched over to the TX text control. PowerBuilder 12.6 is where we first got the ability to do 64-bit compilation. PowerBuilder 7 2017, we had PDF generation before using GhostStrip or XLS FOP, but now what we got is the native ability to do PDF generation. And then rich text editing in this original version of 2017, they didn't have an agreement in place. This is the first Appian version. They didn't have an agreement in place to use the TX text control. So you could still use that, but you had to obtain your own license. Instead, Appian introduced a TE edit control, a wrapper around the TE edit control to do rich text editing. PowerBuilder 2017 R2, more changes to source control. We still have the MSS CCI option, but now we have native drivers for Git and SVN. Now, you could have talked to those earlier using some plugins that acted as a bridge between MSCCI and Git or SVN. Agent Git, Agent SVN. There were some push OK products that also provided some bridging capability there. But now we could talk directly to Git and SVN. PowerBuilder 2019, the GA release, brought back the TX text control as an OEM option. So now you didn't have to obtain your own separate license. You could go back to using TX text control. The TE edit control is still available, though, in that version. PowerBuilder 2022 GA, the TE edit control was removed. Now the only option is to use the OEM of the TX text control. So if you are using text control, depending on what version of PowerBuilder you're migrating forward from, you may need to look at what the current control is. If you're using 10.5 and you were using TX text control and you move to 2022, you're still using TX text control. There shouldn't be really any major differences there. It's just if you were there in the middle where the TE edit control was being used instead, you may have made some modifications to work with that. You may need to revert those modifications now that we're on TX text control again. Okay, I'm going to look at some specific cases here. So the PowerBuilder Foundation classes, there is a version on the open source PFC libraries site on GitHub. There is one for 2022, and it will work with 2022 and 2022 R2. The biggest problem I've seen with people trying to migrate an application when they've been using PFC is they didn't handle changes to the PFC correctly. And by changes to the PFC, I meant changes that they incorporated into PFC. The way it was intended to operate is they gave you, this is, Sybase originally developed this before it was made into open source. They gave you a set of PFC libraries which had source code in them. And they gave you a PFE set of PFE libraries which were just descendants of all the PFC objects. And they also gave you a PFC extender. And what that would do is it would go in and handle inserting a third layer between the PFC and PFE layers. Now, you don't need to have that. It's pretty easy to do it manually as well. The idea being is, let's say I want to modify the behavior of the data window, the PFC data window control, which is UDW. So it's a wrapper around the data window control. So in the PFC layer, it's called PFC underscore U underscore DW, and in the PFE layer, it's just called U underscore DW. What you were intended to do was create a whole set of PFD libraries. You would create a descendant of PFC UDW in the PFD layer, perhaps call it PFD underscore UDW, and make your changes there. And then you would change the ancestry of UDW so it pointed to your new PFD layer. So what you could do is you just could go in and inherit from your new PFD UDW and call the new object UDW and overwrite the one that was in the PFE layer, because the one in PFE layer had no code in it. So it's fairly simple to do that. So what happens when you get a new version of PowerBuilder and there's a new version of PFC to go with it, you go and replace the PFC layer, which you didn't modify, and you take the PFE layer and you just repoint the ancestors that are in your PFD layer. That's the ideal. Problem is, many people edited the PFE layer, and so now they can't just replace the PFE layer with the new PFE layer. They got to go through and figure out what objects need to be added, what objects need to be removed. That's still not too bad. It's a little work, but it's still not too bad. The one that's really an issue is when you've actually changed the PFC layer yourself, and now there's a new PFC with its own set of changes. There was a utility available for a while called ProDiff. Last time I checked, the website had gone down in about June of 2023, and so I'm not sure what's going on there, which is unfortunate because the Pibbles are a proprietary format. That was the only tool that could, that I knew of at least, that could go in and compare two sets of libraries and tell you what the changes were to all the different objects. What you may need to do is, if you need to try to figure out what's different between the two PFC layers, is export the source code and compare them manually. And so it's a lot of work to do that, and that's why I'd recommend, at least going forward, use the new PFC layer. Don't modify it. Make your changes in the PFD layer. So I'll get off my soapbox there and talk about Unicode. This isn't quite as much work. What happened in PowerBuilder 10 is we went from ANSI to Unicode, and what PowerBuilder did, and actually did a pretty good job of it, and any later version of PowerBuilder, if you're migrating something from 9 and earlier, it will go through and look for external function calls that pass strings. And if it sees those, it will append an alias for function name _ANSI to them to tell itself at runtime that DLL, that API call, whatever it is probably ANSI, since it was being called from an ANSI version of PowerBuilder. And so that it needs to convert the string arguments in this function to ANSI before it sends them in, and anything it gets back, it needs to convert to ANSI again on the way out. Now, and if you've already got alias for function declarations on your external function declarations, it'll just append the semicolon ANSI to them. What I recommend, though, doing once you've done your migration from pre-PowerBuilder 10 code to a more recent version is to go through and actually clean up those function calls. And so that they actually call, for every Windows API function that took ANSI, there's also a Windows API call that takes Unicode. Usually, it will be the same name. Actually, often what would happen is the function actually would end in an A for ANSI. So file exists A, as an example. Well, there's also a file exists W, and W standing for wide, meaning Unicode. And so what you could do is go through and find those API calls, those external function calls that are originally taking ANSI, and convert them to call the Unicode version of the function. And then therefore you don't need the semicolon ANSI, and PowerBuilder doesn't need to be converting back and forth from Unicode to ANSI. And then the last case has to do with if you are going to move to 64-bit compilation, which is the feature. It first became available to us in 12.6. It really didn't start working correctly until 2017, though. But it's firmly, it's well fleshed out now, works well. But it is going to take a bit of migration to get there, and there's a number of things we need to look at here, and we're actually going to go through each of these. So let's talk about database drivers first. Database drivers are usually Windows C++ DLLs. That means they have a bitness. The native drivers do. ADO.NET would not be a case of that. But all the other drivers are going to be native C++ DLLs. They'll have bitness. And so you'll need to have both layers. Well, you'll need to have the 32-bit layer installed where you're using the PowerBuilder IDE, because the PowerBuilder IDE is still 32-bit. So in order for the PowerBuilder IDE to connect to the database, you need the 32-bit drivers. If you're going to be testing the 64-bit application you're generating on your local machine, you're going to need 64-bit drivers installed as well. That can, in some cases, confuse the applications, because if both of those are in the path, you might end up trying to load the 32-bit drivers from 64-bit or vice versa. One way to overcome that is in the registry. There is what's called an app path entry under Windows current version. You can go in there, and every executable on the machine, including the PowerBuilder IDE, has an app path entry in there. And what that is a where you can add application-specific path information. So you can add the directory for the 32-bit drivers to the app path for the PowerBuilder IDE, and then the PowerBuilder IDE will load those using that search path, that application-specific search path. And then for your compiled application, you would create an app path entry for your 64-bit application and point it to the 64-bit directory, and then it would load that appropriately. ActiveX controls. ActiveX controls are C++ libraries. They have bitness. So once again, the PowerBuilder IDE is 32-bit. You're going to have a 32-bit version of that ActiveX for the PowerBuilder IDE to use. But then you're also going to need a 64-bit version of that ActiveX for your 64-bit application to use. Now, when you have an ActiveX, there's a utility called regserve.exe that's used. You run that on the ActiveX, and it creates registry entries that are used for so that the PowerBuilder IDE or the application can access the ActiveX. Now, Microsoft, in its wisdom, decided to take the 64-bit version of regserve.exe and put it in something called Windows System 32, and it put the 32-bit version of the regserve tool in Windows SysWow 64. So, yeah, that's just the way they did it. One thing you can do, though, if you don't want to have to deal with registering the ActiveX control at all, is you can use a manifest file. A manifest file is an XML file. What it'll have is the name of the application, .exe, .manifest. So if your application is myapp.exe, your manifest file will be called myapp.exe.manifest. And what you can do is you can take the information that would normally go in the registry and you can put it in the manifest file. You put the manifest file with your application, and then Windows automatically knows if I see a manifest file, I will read that first, looking for registry information. And there's some tools out there that can help you create these manifest files because they're rather difficult to put together by hand. So I'd recommend taking that approach. That frees you up from the registry, which normally requires admin privs. So it's a great tool to use even if you aren't going to go to 64-bit. Okay, so let's look at PowerBuilder extensions like PBDOM or some third-party extensions. I wrote one called PBNI SMTP that allows you to do SMTP. That's been basically rendered unneeded now that we have a native SMTP support in PowerBuilder itself. But that's an example of a third-party extension. And it's a C++ DLL, and that means it has bitness, which means that you need a 32-bit version for the PowerBuilder IDE and a 64-bit version from your compiled application. That's going to give you some something to consider here for your PowerScript code, because you'll need to know what version to run, whether you're running the application out of the PowerBuilder IDE when it's 32-bit or when it's running under 64-bit as the compiled application. How does the application pick up the right version of that extension? Now, one thing you could do, keep the extension file name the same, and then just deploy the 64-bit version of the extension with your 64-bit application, whereas you keep the 32-bit version of the extension with PowerBuilder. That's one way to do it. The other thing you can do is rename them. Have a different name for the 32-bit version and the 64-bit extension. Import them both into PowerBuilder. Then what you do is you use if then else logic in the PowerScript code to determine which of those extensions to use. There's an environmental object, and you use the get environment object in PowerScript to get the environmental object. The environmental object has a process bitness argument now, and that will tell you dynamically at runtime whether you're in 32 or 64-bit mode. So that's what you test in your if then else logic to determine which of those extensions to load. Windows API functions are 32 and 64-bit. Now, Microsoft did a really good job, though, of minimizing the differences between the 32 and 64-bit Windows API calls. One place they really couldn't do anything about is just the fact that pointers, which are that's how you refer to memory space, when you're using a DLL, because the 64-bit has access to much more memory space. The pointers need to be larger. They need to be able to access a 64-bit memory space. That's something Microsoft couldn't work around. You need to support bigger pointers. Now, what PowerBuilder did, in order to make it easier for the PowerBuilder developers, is they introduced a special long pointer type data type. And that data type dynamically changes its size depending on whether or not you're in a 32-bit or 64-bit mode. So if you're in a 32-bit mode, a long pointer is 4 bytes. If you're in a 64-bit environment, the long pointer is 8 bytes. So all that basically means is that when you're looking at your Windows API functions and you notice that one of them is taking a handle as an argument, that you change the argument type from, it's probably going to be a long or ulong, you're going to change it to long pointer. and then it's automatically going to be the right size, regardless of whether you're 32-bit or 64-bit. The other issue you're going to run into with Windows APIs, though, is the number of the Windows API functions. The ones that take a structure, oftentimes the structure will have like a CB argument as the first argument in the structure. And what that takes is the size of the structure. That you pass that in. And the reason they did that was for versioning. So they could have the same API call, and they could have multiple versions of it. They could modify that API call, change the structure that's passed in, and you would just pass in a different structure size as in that first argument, and Windows could figure out which version of the API call it would actually run. Well, the problem with that is that structures have different sizes in 32 and 64-bit. So when you're calling a Windows API function, and if you're calling one of these functions that takes a CB parameter, you probably have the size in there right now of the 32-bit structure. What you need to do is figure out what the size of the 64-bit structure is, and then add in that if-then-else logic that says, if I'm in under 32-bit, pass the original value, but if I'm under 64-bit, pass this new updated value that's the 64-bit size of that structure. External DLLs, much the same issue. Well, as some of the other things we've covered earlier, 32-bit and 64-bit because they're written in C++. And what you'll need to determine, like we covered with the extensions, is do I go with the same name and just deploy a 32-bit version of that to the PowerBuilder IDE and a 64-bit version of that DLL with the application, or do I give them different names? And if I give them different names, what I'm going to do is I'm going to local external function call declarations for both the 32 and 64-bit version, and then I'm going to use, once again, the if-then-else logic to determine which one to call at runtime based on whether or not the code is running under 32-bit or 64-bit. And some miscellaneous things we need to deal with. In a 64-bit operating system, 64-bit applications are deployed under the program files directory. On a 32-bit system, the 32-bit applications are under program files. On a 64-bit system, 32-bit applications are deployed under a program files 86 directory. Primarily what that means is you need to review your code, make sure that your code is not making assumptions about where it's located, or if it deals with the different directories it might be in correctly. Also, the registry, there are actually, it's not exactly like there's two registries. What there is, there's just one registry, but you go under like H key, current key, and there'll be a set of entries there, and then you'll see what's called a WOW6432 node subkey, and if you look under there, there's going to be another set of entries that match the ones that it's under. And what that is, that's the 32-bit registry. That's where 32-bit applications access the registry at, whereas the main branch is the one that 64-bit applications access. So once again, if you're like using Windows API calls to get the registry, you need to be careful about where you're trying to access it. In the original PowerBuilder, up through PowerBuilder 2019, the PowerScript registry methods actually are a bit flawed there. They actually access the 32-bit directory regardless of which bitness they were running under. That's been corrected as of PowerBuilder 2019. If you're using the PowerScript functions, they will access the correct registry automatically. Okay. So here's some resources. One I've already mentioned. It's the PowerBuilder, the Migration Assistant tool, and what you're going to do is you're going to run that once again before you attempt the migration, just to see what it identifies as code that's going to be an issue, and so you can mitigate it before you even attempt a migration. There is a Appian migration guide. Now this is where I mentioned that there was a resource that went back all the way to 6.5. That's it. So that I've got a short URL there that will, and it goes into much more detail than I've covered here, as into what the different versions, different deprecated features were for each particular version of PowerBuilder. Appian also has a very good guide on upgrading targets, so I've given you a link for that. And then there's a guy named Terry Voth. He was one of the Team Sybase, Team PowerSoft guys. He had a website for a while called TechnoKitten, and he had a really good article there on migration. He's moved on and no longer maintains the website. In fact, it's no longer available. However, it is available through the Wayback Machine, the Internet Archive. So that link I gave you there is to the version of the website from the Wayback Machine. So you can still access the article, and I'd recommend that. So now we're going to do an actual walkthrough of a migration. So what we're going to do here is take a PowerBuilder 9 application and migrate it to PowerBuilder 22R2. And so this issues zip file. It contains the application, and so I'm going to extract it into a directory. I'm going to keep that zip file. I've got it up on my Google Drive. I've got several copies of it, because if something goes wrong when I migrate these pebbles, it gets basically the data gets, the files get corrupted. I'm always want to be able to go back to that zip file and unzip it and replace these pebbles with something that I can open with the original version of PowerBuilder I'm migrating from, and address whatever caused the problem in the migration, and then attempt it again. So yeah, keep a backup of those pebbles. Since I downloaded this from the internet, I need to go in here and just make sure that all those files are writable. So that's what I'm doing there. And now I'll go over to PowerBuilder. And there's a couple ways you can, well, the first thing I'm going to do, even before I attempt to migrate it, is I'm going to run the migration assistant. So File, New, Tool, Migration Assistant. Make sure that it's set to do PowerScript. Notice this has been updated. It goes all the way through 2022 R2. And I'm going to navigate to that folder where I downloaded those files. There's the pibble, or extracted the pibble. And so that's all the libraries that are involved. Now this is not going to modify those libraries. This is just going to read them. It won't be until we get to the actual migration that we run the risk of mangling the code. What this is going to do is it's just going to tell us what we may need to address, particularly what we may need to address using the version of PowerBuilder we're coming from before we attempt the migration. So most of this, what it's doing, I'm doing some Ole automation here. And as you may be aware, with Ole automation, it doesn't fail at compile time if there's a syntax error. It fails at runtime. And so I've got all kinds of exception handling around all those Ole automation calls. So that's mainly what it's throwing up here. But there's a few other things here. There's the POSW, which is a revised function. Let's see here. Last position, which is a revised function. There's the connection object, the INET object, internet result object are all obsolete objects. And those are in the PFC layer. So when I change on my PFC layer, that's going to automatically, they'll automatically go away. I don't have any actual references to those particular objects in my code. So I don't need to worry about mitigating that. And everything else, this basically all this is the same. So there's really not a whole lot I need to do here as far as this original code before I begin my migration. So to do that, there's a couple ways we can do it. I could just say File, Open Workspace, navigate to that workspace file and open it up, and it would automatically start the migration. The issue might be, because this was coming from PowerBuilder 9, the source code, well, let me go ahead and start there's another way you could do it. You could create a new workspace, and you could add the existing target to that workspace and would do the migration. I want this. What I'm going to do actually is go in here and delete the workspace and the target file. And the reason I'm going to do that is because, like I said, it's PowerBuilder 9. Let me go ahead and start this, and I can explain while I'm doing the migration. So I'm going to create a new workspace file. But we don't have a target yet. And what I'm going to do is I'm going to say new target existing application, select the application object, add the remaining libraries, take that one back out because that one got added when we added the application object. Okay, and then I'm going to fire this off, and then this will take about 2 minutes. And so that gives me some time to explain what's going on here. So this was originally a PowerBuilder 9 application. PowerBuilder 9 was using the MSS CCI interface for source code control. When you used that interface, you would put each library into a separate folder. And that was typically how that worked. And so that target file referenced all those folder locations as the locations for the pibbles. Well, as you notice, that's not the way that those files were located when I extracted them. They were all in the same folder. And so I've got a choice there. I can either recreate that folder structure, which I don't want to do. I can manually edit the PBT file to make sure to have it reflect the way the new flat location of all the pibbles. Or I can just, as I've done here, throw away the target and the workspace file, create a new workspace file, and use this process, which creates a new target file for me as it does the migration. So anyway, that's why I did that. So this is going to grind away for a little bit longer. Like I said, it takes about 2 minutes for this particular application to do the migration. Your mileage is going to vary. I have another application that's got it's much bigger than this. It's got like 1,000 objects in it. It takes a considerably longer to migrate. This one's a smaller application. It's doing a connect to the database. One thing I'll mention here, I did say this is a PowerBuilder 9 app. This is actually an app we still use, but it's not written in PowerBuilder 9 anymore. It's already in 2022. But what I did is, every time we did a release of the application, we would store off the pibbles that had been used for that release. And so that's essentially able to climb into a time machine and went back to 2005 because we had these releases. Every time we did a release, we stored it off in a new folder. And so we had releases going back to 2005. And so I was able to grab the pibbles from 2005. What I wasn't able to do, though, is I wasn't able to grab the database from 2005. So actually the migration is complete here. So what I'm going to be able to do is show you doing the migration, mitigating some of the issues, but we're not going to be able to actually run this because I don't have a database to run it against. So there's a few things I'm going to want to look at. One of them is I talked earlier about migrating the PFC layer, and I'm going to go off in a little soapbox here, a little tangent. Let me go back to a different workspace. So this is a PFC-based application, and I'm going to show you how the original authors of PFC expected that you were going to extend PFC with your own code. So you notice there's the libraries that all start with PFC. Those are the ones that actually contain the code. And then there's the libraries that start with PFE, which contain the descendant classes that you actually reference in your code, your application code, but that don't have any code in them. And so let's say I wanted to extend UDW, add some of my own custom functionality to UDW, the data window control user object. What I would do is come in here and say new library. I would call that library PFD main. So it's the extension library for PFC main. It's going to become between PFC main and PFE main. And I'm going to take the object that I want to extend, in this case PFC UDW. I'm going to inherit from that. And then I'm going to save that new object into that PFD main. And I'm going to call it PFD UDW, so to indicate that it's the intermediate data window control, user control. And at some point, I would then add code to that to provide that extended functionality. And then lastly, I'm going to go down here to PFE main, find the UDW there, do an edit source on it, and instead of having it inherit from PFC UDW, it now inherits from PFD UDW. And so if you've done that, if that's the way that you've implemented your PFC-based applications, what you do then when you come to migrating to a new version of PowerBuilder is you do the migration first. So your PFC layer is in the current version, let's say in this case 2022 R2. And now you can replace this PFC layer, and you can you'll have your own PFD layer in the middle there, and then with the new PFE layer, all you need to do is go in through there and say, okay, what PFD objects do I have, and make sure the PFE layer objects inherit from the PFD layer. That's if that's the way you did the your extension of PFC. In this particular application, they migrated to PFC about a year or so before I started with the company, and they directly edited the PFE layer. So that's going to be a little bit more problematic. Not a whole lot, but it's a little bit more problematic. And they actually put their own layer above it, and rather than in the middle. So when we've got a case where we've got an existing PFC we want to replace with the most recent version, the main thing we need to look for is remember that what you're going to get from the open source libraries and the PFE layer isn't going to have any code in it, and you've got some code that has been added there. But all you're really concerned about in that case, though, is what's been added and what's been removed as far as objects. You don't care about objects that you've modified, because the one that you're getting from from the PFC, open source PFC, doesn't have code in it anyway. So you're going to keep your version. You just need to know if there are new objects that you need to add to your PFE layer, or if there are objects in the PFE layer that you have that are no longer in the current version of PFC and that you need to remove. And you might have to mitigate the fact that those objects have been removed. Actually, I'm going to switch back to that other workspace for a minute, because you might want to just look at the library list itself. That seems kind of onerous task and is subject to a little human error. There's a ProDiff from Ken Howe, that does a great job of not only analyzing what objects are new or removed. It also does diff on object changes. We don't need that for this though. And what I actually did is I wrote a little utility here. This one, compare pebbles, which will go in. This is if you didn't have ProDiff, you could just use something like this. So I am going to look at this is the PFC 2022, and I'll look at PFE main, and then I'm going to go to this app that I've just migrated and look at its PFE main just to see, okay, what are the differences? And say go, and so these are all the objects that are new in open source PFC. So what I know I can do is I can go and find those objects in the open source PFC and just copy them into the PFE main in my library. This is where you might need to do a little mitigation. They added, these are all structures that were added to the PFE layer that they've been modifying. Actually, I don't think there's any mitigation needed here at all. These are used for external function declaration calls, and we need to keep those for some of the added functionality they added to the PFE layer. So the only thing I really need to do here to upgrade PFC for this particular application is replace the PFC layer with the PFC layer that comes from the open source project, and then add these new objects, and you'll need to do that for each of the PFE libraries. This is just one of them, but it's the one you're probably going to see the most changes in. So that's migrating PFC. There's a few other things I want to look at here. Let me go back to the library that we were actually migrating, and I'm going to search for a particular function. And what this is used for, there's a bit of a long-winded explanation here. It's a client-server application, and what that means is that the user is actually logging in with a database account. And we're using Oracle, and what we do to protect the database from the user logging in through some other tool and being able to access the tables and modify data outside of our business rules is we use a role. And the role has the privileges. We set the role to the user, and we don't want it to be a default role, because if it's a default role, then when the user logs in using Microsoft Access or something, they could do the edits. And so what we do is when we log into the application, we set the role at that point. Well, the problem we were running into is that when there were issues we needed to debug, sometimes we'd ask the user to open up their INI file, put in the TRA in front of the DBMS parameter, and we get a trace file. Well, what's the first thing that showed up in the trace file? Well, it was the set role command that gave the user privs to modify data. And so we were at some risk there. So what this utility I've written does is I'm looking to see, actually two things. I'm looking to see if they've got trace mode turned on, or if they've got server failover, fast failover turned on. Because if it's got fast failover turned on, PowerBuilder will do the failover for you. Unfortunately, the set role doesn't get carried over, and unless you do a little extra work. And in this utility I wrote, I do the extra work, so that if there is a fast failover to another server, the set role gets applied and the user can still use the application. Anyway, so I wrote a DLL, and I take the existing database connection, I pass it into the DLL, and I do that work, that fancy work, with the existing database connection through that DLL. So that was originally, this is the declaration for it. And you'll notice that it got set roll, you got the semicolon ANSI put on it because the strings are being passed. And it's assuming that that this is an ANSI DLL. And we need to convert the Unicode that PowerBuilder now is to ANSI before we call the DLL. Well, when I went in and started looking at what I needed to do to support 64-bit, not only did I write a 64-bit version of this utility, I also converted the original one to Unicode. So I don't need to have the semicolon ANSI there because this is a Unicode DLL. And so that's that one, but I also have another DLL for 64-bit. So I'm going to put this and I named it two different files names. So that's why we're doing this. If I had used the same file name and just relied on deploying the correct file at runtime, actually the 64 goes here, not there. The function is called setroll in the DLL, but I've got a 32-bit version it's just called setroll DLL and a 64-bit version called setroll64.dll. So I now have two function declarations. Let me save that. And then I'm going to go to where it's called. And now we need to see what mode we're in. So I'm going to do a get environment. Which means I need to go up here and declare an environmental object. And once I've got the environmental object, now I can do actually, this goes here when I'm calling the DLL. So I say if env.process, hang on, there we go, process bitness equals 32, then I call my original DLL, else, and we're going to assume that is 64-bit. I call the 64-bit declaration. Okay. And that compiled. Okay, so that's example of dealing with an external DLL to support both 32-bit and 64-bit compilation. Okay. So that's one issue we had to deal with. Let's take another look at another one. This is a Windows API call. And I want to find the declaration for it. So it's going to be under local external functions. This is the Unicode migration. So it's down here. There we go. Get temp file name. Notice over here it has the alias for and then has the A. We actually in our declaration already had an alias for. We had alias for get temp file name A. End quote. And PowerBuilder is pretty smart. It sees if the alias for is already there, all it does is append the semicolon ANSI to it. So our code references get temp file name. It doesn't know whether or not it's the ANSI or Unicode version and doesn't care. But what I was recommending though is that you actually go ahead and change this to the Unicode version. And that way PowerBuilder doesn't have to do the conversion from ANSI to Unicode and Unicode to ANSI. It just stays Unicode throughout. And save that. So that's, you don't have to do that. You can stay with the ANSI if you want. I'm just recommending you might want to look at going ahead and going to Unicode. Okay, I'm looking at another issue that you have to deal with. We make a number of Windows API calls to deal with the WinSCAR DLL, which is what's used to talk to smart cards. And I typed that wrong. Let me try that again. And I just happen to know by reviewing the Windows API declarations for these calls that we're making that these structures here have this PB data element, nothing to do with PowerBuilder, which are pointers. And in 32-bit, a long is fine, but for 64-bit, it needs to be bigger. And now we're using that amorphous long pointer data type, so it makes a 4-byte call when it's running in Windows 32-bit and an 8-byte call when it's running under 64-bit. So you make that adjustment there. So you're going to, if you're going to be looking at moving to 64-bit, that's one thing you're going to look at. Review your Windows API functions, figure out where pointers are being passed, and modify those data types. And it could be in the structure, as in this case. It could be in the arguments to the API call itself. Look at something else here. The shell execute EX function. We use this when we write out PDF files and we want to automatically display them to the user. Actually, in this particular window, this is just a list of file attachments. And so what we do at runtime is we figure out what is the application that is, we use shell execute to automatically launch the application that's associated to the extension for the file that is in the window. And so we have a local external function here, shell execute EX. And one of the things to note is that it's calling the A version, and we can change that to W. But there's something more important we need to do with. This is one of those functions. Let's look to see where it's used. Where there's a structure. This is the structure. It's called. Scroll back up to the top here. It's called shell execute info, or shell execute info is the name of the function, and S underscore is the prefix we put on it for PowerBuilder. Okay, so we go back down to where this is getting called, and you notice there one of the first parameter, the first data element on that structure is CB size. That's that flag where you pass in the size of the structure, and the size of the structure is going to differ between 32-bit and 64-bit. So once again, I'm going to do a get environment. That means I'm going to have to go back up here and declare environment variable. And then say if env dot, come on, not sure why I type it wrong up here. Apparently I don't know how to spell. There we go. Process bitness equal 32. Then I go ahead and use that value. Else, and this may take some digging to figure out for your different functions, because it's not mentioned in the Windows API documentation. Because if you're working in C++, you can just use a size of function on your structure, and it automatically passes the size. But that's the size of this structure in 64-bit. And so that's really the only change we need to make. We just need to make sure we pass that higher value for the structure size when we're running on 64-bit. Okay, and just save that. And then, yeah, there we go. Okay, and there's one more I was going to show you, and this is kind of the one that got away. This application actually got deployed to production with this issue still unaddressed. So there wasn't a huge issue. We didn't catch it in testing because what happens is this particular function, there was an issue. What it does is it looks to see if there's an INI file for the user in their app data directory. And if it can't find one, it creates one with some default values. When we were testing, we had already created the INI file, and so this particular routine never got tested. And then when it got deployed onto new machines that didn't have the INI file, it was getting some bad values included in the INI file. And we have to keep going in and editing the INI file that got created to update the values to correct values. So what I have is a function that goes out and uses the version info Windows API calls to go see what the version number is of the OCI library that's being used. And as you may know, if you go look at the database drivers, there isn't an 084 anymore. 084 is gone. There is an 090 and an 010, but that's for Oracle 9 and Oracle 10. That's history. That's long history. The current driver that we should be using is ORA. That's the up-to-date current driver. It's funny. There were two applications we modified. I took an internal application and migrated it first to test out doing the 64-bit compilation, and I caught this when I was doing that migration. And when I did this one for the client, somehow I missed this. And really, this is just kind of making sure that your database driver information is up to date. So we really don't even need any of this anymore. This could all be replaced with that. I don't need to call that function. I don't need to branch. None of our users are anywhere near anything as old as Oracle 10. So we can just use the ORA driver. But I thought it'd be interesting for you to see. I sometimes even I let stuff get through, and that's, in this case, that certainly did. And maybe that will save one of you running into that same problem. Okay, that's pretty much everything I wanted to show you. So let's go back to the slides. Okay, so that's the end of the session, and it's time for questions and answers.